Looks like we're live. Hello everyone and welcome to yet another Zosin session. How about that? How about that? So let's make a little bit of an announcement and officially start the stream. Hello everyone. I'm really glad to see you all today. So let's wait until Discord actually recalculates the layout. And let's do a red circle live on Twitch. Right, live on Twitch. And what are we doing today on twitch.television? Today we are doing something special. Today we are rewriting a bash script in C. That's what we're doing today. That's the level of content I'm at these days, right? So that's what I'm doing. I mean, streaming business is hard, right? So you have to pull out the big guns, right? So that's what we're going to be doing today. We're going to be rewriting bash script, not bash but bash, right? So I don't speak English. I don't know what's the difference between and other vowels of English language, but essentially we're going to be continuing developing Olivet, which is the graphical library that we've been developing for quite some time. I'm going to give the link in the chat, and also I'm going to put it in the description. For some reason I closed my Emacs, right? So let me quickly open my Emacs. So with this library you can do simple graphics in the memory, right? So it's a purely in-memory graphics library. You can ask it to render certain graphical primitives into the memory pixel by pixel, and then you can do whatever you want with that memory. This library is not concerned with how you display those pixels yet. I do plan to actually add a little bit of awareness of how you display the pixels in the future. Right, so for example, for the demos I developed quite a bit of code to have these sort of animations, and this specific code might be useful as a part of the library. So a lot of the stuff that is developed for demo and not part of the library probably soon is going to become part of the library, so we can replicate these demos easily, right, and maybe extend and add more different ways to display the things. I think it's going to be useful, but of course in the future you also will be able to disable all of the dependencies and go completely dependenceless, right? And in case you want to do something special, for example embedded, right? So anyway, so this is what the library is capable of doing. So we even have a little bit of a 3D, right? So texturing and stuff like that. We have even models, 3D models. They're kind of slow because, again, all of that is on CPU. But for a CPU graphics, this is relatively fast, reasonably fast. It's actually quite surprising that this is completely CPU. Nothing on GPU. This is not OpenGL, this is not WebGL. We're rendering this motherfucker pixel by pixel. And how the fuck is this not less than 1 FPS? This shit must be less than 1 FPS. And this is a 10 years old laptop. Keep in mind, like, just imagine how fast your computer. This is in a web browser on a 10 years old laptop, from which I'm also streaming and re-encoding. Like, just think about it. That's how fast your computer is, without any GPU acceleration or anything like that. And now try to open Twitch. What the fuck is going on? Seriously, what the fuck is going on? Your computer just by itself, without any GPU acceleration, is capable of so many freaking things. What the hell is going on? I don't freaking know. I think we are forgetting how to write software anyway. So today we're gonna remember how to write software. So by itself, the library that I'm developing doesn't require any special building, right? So it even says that in the README. So let me actually see. The library itself does not require any special building. You can simply copy-paste olive.c to your project and include it, because the truly reusable code is the one that you can simply copy-paste. The library itself doesn't require any building whatsoever. You just copy-paste the file and you got the library. However, we still have a little bit of a building process involved for the tools, right? So for example, we have the demos. You can build the demos just to test them, just to see them. You also have tests, and to build all of that we use a build.sh shell script, right? And recently this shell script was supposed to be very simple, right? So basically I was thinking that I'm going to rebuild everything at once in a single script, but I've added too many things, right? I've added a lot of different demos for different platforms like WebAssembly, like a terminal, SDL, and stuff like that. We have a shed ton of demos. Like, look how many demos do we have? We have 8 of them, right? And for each demo, we actually built 3 versions, so 3 by 8, 24. So basically, we built 24 different demos. And on top of that, we build in additional tools that allow us to convert the assets, right? So PNG images and OBJ files. OBJ files are 3D models. What we do, we process all of those things to turn them into C code that we bake into the demos, right? All of that is done within this simple shell script. So, and it feels like the trend is that it's going to become more and more complicated. So we need to finally rewrite this shell script in a proper programming language, right? So as your build system becomes more complicated, you want to use a proper programming language. You don't want to use shell scripts, right? So here's an interesting question, like how do you solve this kind of stuff, right? How do you make a better build system? So essentially, we could use one of those build systems like CMake, but I really don't like them because they're rather overcomplicated. And the CMake scripting language is yet another scripting language. It's just like so lousy, and it's just like doesn't feel robust enough for me. On top of that, CMake is building tool on top of building tool, right? So you need to have CMake. On Linux you also will have to make, and on Windows you'll have to have Visual Studio, and I just want to build a bunch of C files, right? Why just to build a bunch of C files I need so many different tools? You know what I mean? Right, so in fact I believe that to build a C project, purely C project, you should not have anything but a C compiler. And that brings us to an old project of mine. Some of you already in the chat guessed it correctly. Yes, everyone, like a lot of people in the chat probably heard that rhetorics before, right? So we're getting back to nobuild. There we go. So we're gonna port our build system to nobuild. That's right, I'm gonna put that in the chat. I'm gonna also put that in the description for everyone who's interested. Nobuild is freaking awesome and I want to get back into using it. And it's actually perfect for what I'm doing right now. So essentially, right, nobuild is a build system. So basically it's a header-only library. It's a header-only library, single file header-only library for writing build recipes in C. It's more like writing shell scripts, but in C. So, and there is a lot of justification on why you want to do that. So different advantages, disadvantages. I really recommend you to read all of that. But essentially, in a nutshell, you end up with a build system that doesn't require anything but C compiler to build the entire project. Right. So in case of using CMake, you need to have a C compiler, CMake itself, and the lower level build tool like Make, Ninja, or Visual Studio, right? So you already have to have so many different things. If you're writing, for example, Python script to build your entire project, well, you need to have a C compiler and a Python interpreter. Like, why the fuck do you need two separate languages to build a C project? You shouldn't have that. So you have a C project, you should be able to build the entire project with a C compiler. And this is nobuild is all about. So essentially with a C compiler, you bootstrap your build system and then the build system builds everything else. That's how it works, literally. So you just build your initial thing, right? So you have a nobuild.c, you create nobuild, you then run that nobuild, and that nobuild builds everything for you. So there you go. So this is actually pretty cool. I use this thing in a couple of my other projects and it worked reasonably well. We developed it for several platforms. It also supports Windows to some extent, right? So if you take a look inside of this entire thing, it includes Windows files. So this is Unix and this is Windows essentially, right? So yeah, so we're gonna try to port this build system to C. So we've got some subs, I suppose. Thank you so much, Lazy008 for tier 1 subscription. Thank you. Really appreciate that. So let's go ahead and try to do that. So I'm gonna go to build.sh. So what's funny is that if we're gonna port that to C, we can actually translate this entire thing one-to-one to C, so it's actually reasonably easy to do. Thank you so much, Sir Maxwell, for Twitch Prime. Thank you. So let's go ahead and download nobuild.sh. And then I want to download the raw file. Yeah, there we go. I'm gonna literally wget this entire thing into my project. All right. Here is the nobuild.h. So, and let's create a nobuild.c. Let's first of all probably include just nobuild. I was thinking to include stdio, but I think nobuild already includes stdio for you. So since the stb style header-only library, we have to define no build implementation, right? So because by default it acts like a header file, and if you want it to act like a C file as well, you have to say that you know, please include implementation as well. All right, so we're gonna include the arguments in here, and as far as I know, you have info macro that allows you to just print messages. So let's actually say something like hello, say not sailor, seaman, right? Hello seaman. I don't remember if you have to put a new line in here. I think you shouldn't have to put a new line in here. Right, and let's try to do clang o no build.c. There we go. So we've got no build in here. Let's try to run no build, and it says info hello seaman, right? So let's try to do something more complicated than that, right? Let's try to do something more complicated than that. One of the cool things no build has, it has automatic rebuilding, right? So it has a special go rebuild yourself technology. Yeah, there we go. Go rebuild yourself technology. Essentially, you take this macro and you put it at the beginning of your program, and now every time you make any changes to the C file will automatically rebuild yourself without you doing anything. Right, because one of the downside of this approach is that every time you change a build script, you have to first rebuild the build script and then use that build script to rebuild the rest of the project. It's not convenient at all, right? So no build has a patented, no, it doesn't, it's not really patented, but it has a unique go rebuild yourself technology, which actually keeps track of whether the C file was modified or not and rebuilds itself. So for it to work for the first time, we have to rebootstrap this entire thing one more time. So, and let's try to run it. As you can see, it says hello seaman, and let's actually change it to sailor, right? I just changed it to sailor and I just rerun no build without rebuilding this entire thing. And as you can see, it first renamed the executable to the old one, so it made a backup, right? It made a backup, and then it rebuilt itself and it ran the rebuild executable, and now it says hello sailor. If you run it one more time, it doesn't rebuild itself. It actually knows that it already rebuilt itself, right? So now I can just continue doing things, and it will constantly rebuild itself every time I modify this this build script. So this is actually kind of cool. All right. So one of the macros this thing has it has a CMD macro, which allows you to just run external programs. Let's try to build something, right? Let's try to build maybe test utility, right? So let me see, build test. Oh, okay, there we go. So I have a special build utility. Let me actually see. That has different subcommands. And I can run all of the tests for the library. So what it essentially does, it just like tests different aspects of the library. Essentially, like I usually write this kind of unit tests in a bug-driven manner, meaning that I don't really write them like too many of these things unless there is a bug. As soon as I detected a bug, I usually first write a test that detects that bug and then I fix the bug. Apart from that, I rarely write any tests, but sometimes I do. Sometimes maybe if the feature is complicated, I will still write a test for that. I don't really have a specific recipe. I don't really follow any specific methodology. Just have something that I want to test sometimes. So yeah, let's try to build this entire thing, right? Let's try to build it and see how it goes. So we need to do clang, then O, and then we're gonna have test, and then test.c. Right, let's try to actually run this entire thing. And as you can see, so it cannot find the asset file, and this is because the assets files are located within the build folder. Right, they're located within the build folder. So Arena is located in the dev dependencies, so we have to also include this thing, dev dependencies, dev deps. Anything else? Okay, cannot open directory. Linker command failed. File test. Why it cannot open file test? Oh, this is because I have already a folder test. That's why I build everything inside of the build folder. Okay, that's fair enough. So let's also build all that thing in the build folder. Why not? Right, there we go. By the way, this is one of the reasons why I called the tool nobuild and not just build, because quite often you would have a build folder, right? And if you have a build.c in build.h, you probably want to have an executable build, but you already have a folder build. So that's why, that's one of the reasons I call it no build. Of course, I put some, justification of like, marketing bullshit in the README, but ultimately that was the reason why I called it no build. I just need something that is not built, so you don't collide with your build folder, right? So this is one of the reasons. Okay. So let me try to rebuild this entire thing, and it built, but we also need to link with the math library, right? Because it uses something from math library, like sine, cosine, probably for some sort of compression. All right, and there you go. So we build this entire thing, and now it says hello server. We can also try to go ahead and run the test utility after we build it, right? We can try to run it after we build it. And of course, it expects some sort of a subcommand, right? So maybe we want to do something like run. There you go. And yeah, so what's funny, to do all of that, we didn't need any external tool, any additional script interpreter, like even shell. You don't even need shell. You can build it on a system without shell, but with a C compiler theoretically, but POSIX compliant, right? So the only thing it needs is POSIX compliancy. But if you're POSIX compliant, you probably have a shell anyway. But yeah, anyway, you see what I mean. So that's pretty cool. But one of the things this build script does, it also initializes the build folder. It creates the build folder. So if I remove the build folder, I won't be able to run this entire thing, right? Because as you can see, it couldn't even find the assets, right? That's one of the problems we have. It couldn't even find the assets. So we probably need to port the process of building assets as well. And if we want to build the assets, we first need to build the tools that process the assets. Okay, so we probably need to start actually properly, you know, porting this entire shell script. So one of the things we have, by the way, we have these common flags that I had to put like manually. I had to put like manually build and dev depths and some other stuff. So I think I'm gonna copy paste this thing into nobuild. Right, so I'm gonna put it in here, and I'm gonna actually use the macro. Right, and I'm gonna wrap each individual flag into like its own separate string. And why I need to do that is actually rather interesting in my opinion. Right, so all of that is needed so I can just let me just quickly finish all of that, so I can embed all of these things like so. Right, so essentially this macro will expand in here and it will add additional arguments to the CMD call. You see what I did here? Right, so hopefully it will work. I think it will work. So, and I can reuse it with other like commands, with other Clang calls. All right, so this is one of the things, and the first thing we need to do, we need to build the tools, right? So build tools. And again, since it's a C language, I can use everything that I can use in C, right? So like I'm literally programming these things in C. And one of the things that mentioned in the README, in the pros, you end up using the same language for developing and building your project, which may enable some interesting code reusage strategies. The build system can use the code of the project itself directly, and the project can use the code of the build system also directly. So the build system and the project may have a common code. They may have like a common config.h that both of them reuse for whatever reason. Right. With shell scripts, you won't be able to do that. With the other build system, you can't do that. But here, you can kind of do that, which is actually kind of cool, isn't it? So I think the logical continuation of this idea is something like Jai, right? So in Jai, you literally can during the compilation, you can initiate the compilation of another project, you can generate more code and stuff like that. So in Jai, this kind of thing is sort of like more tightly integrated together, right? But here we have to like build separate executables and run separate executables. So we've got more subs. Thank you so much. Thank you so much. Lithium X 4,900. Thank you. So I suppose you guys like this build system if you throw money at me. Thank you, I really appreciate that. All right, so we need to build the tools. How do we even build the tools? Let me see. Build tools. So first of all, we have to create a folder, right? We have to create a folder. So I do remember that nobuild had something for creating folders. So nobuild.sh. Let me find make dir. Oh, you can even create several dirs. Yeah, so path make dirs, and as far as I know, on okay, but I don't quite remember. Does it work on Windows? Oh yeah, so if I remember correctly, make dir works on Windows as well, right? So Windows has like unfinished POSIX layer, and make dir is part of that POSIX layer, more or less, maybe, but maybe I'm wrong. I don't know. So we need to create the dirs, make dirs, and I have to provide several arguments in here, so it's more like a variadic thing. So make dirs, and I just need to do build. I suppose just build. I'm not quite sure why. Oh yeah, because I actually put it in tools. Okay, so let's actually create it like that. Right, so I need to do make dir tools. And let me comment out this thing and just run build tools and see how it goes. Right, so I'm gonna rerun this entire thing, and it created the build folder and the tools folder. Right, there we go. So this is actually quite cool. Right, so if I rerun this one more time, compilation, where is the compilation? There we go, it created this stuff. As you can see, this tool also constantly logs what it's doing. Right, so you always know what it's trying to do, which is kind of useful in my opinion. All right, so nobuild.c. So we do that, And after that, we need to just build this thing. I might as well just copy paste this stuff in here and just wrap all of that in CMD. So here we have common flags. Then we specify the path to the generated executable and then the path to the source code. Right, so this is the path to the source code. There we go. There we go. Okay, cool. So let's see if it actually builds stuff. Oh, it even warns if something already exists, right? So if I'm trying to create a folder that already exists, it will complain about that, but it will not fail the build, right? It will just complain that you're trying to create something that already exists. Right, and after that, as we can see, here is the PNG.c, so which is quite convenient. All right, so let's try to maybe create obj.c as well. So this is the second tool. So both of these tools are needed to take the assets, right? To take these assets that we have in here, so PNG files and OBJ files, which are 3D objects, and turn them into C code that we can bake into the executable. And why you need to bake them into the executable? It makes it easier, for instance, in the web, right? For the web examples to actually initialize them, because you don't need to write a mechanism that enables demos to fetch additional data, because you can bake the data into the WASM blob, right? So we use this kind of tools to actually bake these images right into the WASM blob. This is part of the WASM blob. And for instance, these 3D models also part of the WASM blob. We literally bake them. If you load the WASM, you get those things automatically. You don't need to fetch anything. It's like a Webpack. It's a Webpack written in C, right? These days kids understand things like Webpack and stuff like that. I never used Webpack. I'm too old. I just write my own Webpack in C. That's how old I am. Anyway, all right. So we build these things, and that's pretty cool. One of the things we also do in here is we actually run them in two sort of separate threads, right? In two separate threads. Oh, Webpack is now old. Yeah, so I'm so old that I'm referring to other old things as the new things because of the skewed perception. You know? You know what I mean? Right, so you probably have seen people like that. You've seen probably old programmers complaining, oh kids these days programming in Java. Back in my days, we were like, and Java is already old, I'm sorry to tell you that, right? So it's like another layer of oldness, like an old person complaining about other old thing, which by the time is already old as well. I hate this new SVN stuff. Yeah, exactly. So what people use these days instead of Webpack? So what's the hot new thing, right? So I should know about. So people say Turbopack. Let's actually Google that. Turbopack. So I need to stay on top of my game. It literally says successor of Webpack. You couldn't make that shit up. Holy shit. Okay. All right. Of course, it's Rust-powered successor tool. Of course. I mean, why I'm not surprised. And also Vite. Just so some sort of like a PP size competition going on in here. As PP grows. So who has the biggest PP? Okay, I see. Okay, cool. So let's actually take a look at Vite. Next generation front-end tooling. Cool. I'll keep that in mind. Thank you. Thank you. So instead of Webpack, I'm gonna say now Vite and what was the other thing? I already forgot. Turbopack. Yeah, Turbopack. Anyway. That's how much I care about all of that. So I just look at it and I already forgot about it. Okay, so after we build the tools, we need to build the assets. And not asserts, assets. There we go. So build assets. There we go. And for the assets, I might as well actually like straight up copy paste this entire stuff and just like port it line by line. So I'm matching like a one line of shell scripting to one line of C. Isn't that cool? I think it's pretty cool. Make dirs build assets. There we go. And another epic thing is that I can use multiple cursors to do some cool shite. Like so. Though maybe for these separate things I have to do it separately because they have different amount of elements and different length. So it's a little bit easier for me to do this kind of stuff like that. A boom, a boom. Okay, so this builds the PNG assets. Here we're going to be building the OBJ assets. So this is a scale factor. It's kind of interesting. So I can turn OBJ file into C, but also scale it on the fly to make it a little bit smaller. So yeah, that's what the tooling allows me to do. Isn't it cool? Can your Turbopack do that? Can your Turbopack do that? I don't think so. Your Turbopack probably builds in 2 hours without producing anything useful except the heat. Alright, so let's give it a try. So the first thing we do, we build the tools and then we build the assets, and let's see how it goes. Okay, so we build the tools and something went horribly wrong. Could not execute the child, no such file or directory. Oh yeah, because I'm a silly dum-dum. I forgot to put a comma in here. There we go. Yes, is it gonna work? Yeah, there we go. So that actually worked. As you can see, first it builds the tools, and then with those tools it builds the rest of the things. So if we take a look at the build folder, now we have not only the tools with both of the executables, but also the assets with the C files, right? So essentially, if you take a look at the original assets, right, sodium pogue, for instance, so here it is, it's a sodium pogue. Isn't that pogue? So this is how sodium pogue looks like, but in C. So we literally took the pixels of that image and we turned it into an array, so you can include this file into your C program and it will effectively bake that image into your program, so you don't have to load it from anywhere, you don't have to do anything, right? It's just baked. It's just sodium pogue. Isn't that pogue? I'm pretty sure your Turbopack is incapable of doing that. I didn't think it can do that. So it's a patented technology. So Elazor, thank you so much for Twitch Prime. Thank you everyone who subscribed. I really appreciate that. So you're making full-sized C graphics. What is it full-sized? How do you know if something is full-sized or half-size or quarter-size? What is the... Is there any, you know... How to say that? Like a reference. What's the frame of reference? How do we know if it's full or not? I don't know. So, but what I'm doing is just this. So... This is what my graphical library is capable of. Is it full-sized? Is it 75% sized? I don't know. So, is this C-powered Webpack? Yeah, exactly. So Turbopack is Rust-powered, but my shit is C-powered. That's right. That's why it's faster. Might be not as safe, but it's faster. Alright, so let me see, let me take a look at the rest of the things. So after building the assets, we also build the test, but we already built the test, so the only thing I need to do is essentially I just need to take this entire thing and move it to a separate, maybe, you know, function, right? So let's actually do build tests, and I'm going to do void. And I'm going to just move this entire thing in there. There we go. I'm going to uncomment. I probably don't want to run it. So I have a couple of ideas actually. So in build.sh, in fact, look. So here we have an access to the command line arguments, which means that we can make a subcommands for the build tool. And for instance, we can run the tests through a subcommands of the build tool, right? So yeah, who said we can't just pass some of the sub-arguments to the test thingy? And all of that becomes sort of like tightly integrated together. Isn't that cool? So that's actually pretty cool, I think. I think so. I really think so. Your Vite can do that. I'm pretty sure it can do that. I never tried either of those tools, but I'm pretty sure it can't do shit. All right, so let's actually do build tests and guys, $300 and I will try Turbopack on the street. Probably won't, I don't know. So I need to double check that I'm actually using the correct command line. So one of the things I also use for the test apparently is a fsanitize memory, which is actually a cool idea, right? Just to make sure that we don't have any memory unsafety. Speaking of memory safety, by the way. So probably want to do something like this. Yeah. There we go. So we're essentially building everything. Right, and here we are also building the tests. Okay, so yeah, that's pretty cool. So the next thing we need to do, we need to build all of the virtual console demos, right? So we're getting into the business of building demos, which is rather interesting. So this is going to be something like that. And when we are building demos in a shell script, we actually delegate all of that into a separate subcommand, right? Because for each demo, we are building 3 different versions. We are building WASM version, we are building the terminal version, and we're building SDL version. So I'm going to show you what it means a little bit later. Maybe you know what? I'm going to actually run the build.sh and I'm going to show you what it means, right? So for each demo, you can have 3 versions, and it's actually really cool. Right, so here we are building that with the shell script. You already seen the web version, so it's taking some time because, you know, right, the 10 years old laptop. Thank you so much for 6-month-old X-Rise. Thank you, really appreciate that. Here's the web version, right? But we also have an SDL version of the same thing, so we can do a build demo. How's that? I think it's a Teapot 3D SDL. Right, there we go. It's a little bit faster because it's native, actually, right? So it's not using like WebAssembly or browser, it's through SDL, right? What's interesting, you may ask, how do we even do that with SDL without any OpenGL? Because SDL doesn't have 3D, or it doesn't even have triangles. Well, we use SDL textures, right? So we create an SDL texture, and each frame we render pixel by pixel into the SDL texture. And since our library works by filling up the memory with pixels, it works out, right? So that's how it works essentially. And we also have a terminal version, right, which is even cooler. So let me actually show. You have demo Teapot 3D term, and I need to actually zoom out a little bit, and as you can see, it actually renders all of that into the terminal with ASCII graphics. Yes. And what's funny is that it is compiled from the same code. It is compiled from the same code, the native version, the WebAssembly version, and the terminal version. So yeah, that's what our library is capable of. Well, I mean, there's a lot of additional code that is not a part of the library, but we're gonna make it part of the library in the future. Yeah. Can your Vite or Turbopack do that? I don't fucking think so. They can't do shit. Only consume electricity. That's what they can do. All right, and this is super fast and super efficient. Should stop. All of that shit is gonna get me into trouble. Okay, so let's actually continue passing all of that. All right, so let's create the make deers. Let's continue. Okay, so it also means that we'll have to create a separate sort of procedure that builds a single demo and we'll have to pass the name of the demo. So this thing is not implemented yet, but we're soon gonna implement it at some point. All right, so let me do the following thing, where I'm gonna just boom, 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 boom. There we go. So that seems to be working. That seems to be working. So let me do no build. There we go. All right. Okay, so it's just build. For some reason it actually builds the test. Okay, so it created the demos folder, which is quite important. So the next thing we need to do, we need to implement the VC demo thingy. VC demo. Let's actually put this entire stuff in here. There we go. Boom, boom, boom. There we go. So now we need to implement these three separate functions. So building the wasm demo, building the term demo, and so on and so forth. I wonder if I can just use the multiple cursors here as well. I think I should be able to do that. Look at that skill. It's not really a skill, it's just like I'm using the text editor, nothing special. All right, there we go. So let's start with wasm, I suppose, right? Wasm is quite involved. Oh, it needs to copy a file. Do we have copying the files in no build? I don't remember. Do we have something like that? Nobuild.sh copy cp. We don't have copying files, but do we have moving files? CMD CP. No, it actually means that you gonna depend on the you're gonna depend on external tools. Well, I mean, you already depend on the compiler, but on the external POSIX tool, because I want this thing to work on Windows as well without any special problems, without any problems. Right, so, well, I mean, you can always on Windows just like do conditional compilation, but that would be rather interesting if we just had you know, a facility to copy the file. So maybe I'm gonna like postpone that for now, but we'll see. Okay, so wasm demo. I mean, it's just like an opportunity to implement that at some point. So it's just like you open a file, right? So you open another file and you just read one chunk of the file and just copy it to another. So on POSIX, so specifically on Linux, I think it's a Linux thing. On Linux, we can even use something like send file, right? So we can open two file descriptors and we just like can, you know, transfer it on the kernel or something like that. For Windows, we can try to do something else. So yeah, it's not that big of a deal. Wasm. Oh yeah, so this is where we copy paste it. So we need to copy paste it from the build folder to a wasm folder to deploy it on the website, right? So all of that is needed to deploy on the website. Okay. So this is going to be CMD. So this is Clank. This is a common flags. We also enable a little bit of optimizations, right? Then we disable all of the built-in things. And the reason why I disable these built-in things is explained in old video of mine. Let's actually take a look at it. So if you Google up Tsoding daily, I think why C compiler is so smart, right? So essentially I explained like why I enabled this specific flag in this video, right? So I really recommend to check out this video. Right, there we go. I'm gonna copy paste it in here, and also I'm gonna put that in the description in here. So why I enable f no build flag, right, for wasm, specifically for wasm. So the basic idea is that Clank sometimes optimizes things by calling to built-in functions, right? But since we're not linking with the standard library, those functions might be missing, right? This function might be missing, and if you don't do this kind of thing, right, essentially we'll try to call functions that are not existing, so it will fail with the link error, essentially. Right, that's why we have to say that. It's kind of weird why this is not automatically enabled as soon as we enable no standard libraries, but it is what it is. It works like that. Maybe it is a bug, I don't know. Right, but it would be kind of nice if I didn't have to think about this kind of thing. I mean, the compiler knows more than me. It has more information about this kind of stuff. Why do I have to instruct it to disable some things that it doesn't have an access to? It's really weird to me, in my opinion. Okay, so this thing is rather weird, right? So here we'll have to concatenate, you know, a couple of strings. But as far as I know, no build has a built-in concatenation thing. Yeah? Right, so let me actually see. Concat, yeah, I can literally just concatenate a couple of strings. So I can do concat, right, so then something like this. So here is the name, there we go. So I can just concatenate like that. Maybe it would be better to, you know, move this kind of stuff like that, but whatever. Okay, so here is what kind of platform do we use. And here is the name. So let's do concatenation. Right, so this is another concatenation, a boom, and another concatenation, a boom. There we go. So I'm going to disable this thing for now. And this should be basically it. So let's try to build all of the WASM demos. Right, so and see how it goes, and if it works at all. Okay, it doesn't compile. Because why I forgot, it looks like I forgot a semicolon, so that shit happens. Alright, so what do we have? No such something. Ah, okay. So I have to do something like this, because it failed. It couldn't recompile shit. Alrighty, so we're building. So we're building the tests. Okay, so we're also building WASM. There we go. So it essentially built rather. Okay, so it's trying to do that one more time. For some reason it doesn't allow me to finish this stuff. So why do I have this thing? Okay, so in demos here are all of the WASM files, right? So we generated all of the WASM files. Okay, so what's going to be the next thing? The next thing we need to do the terminal. Let's go ahead and just find the terminal. So this is the thing that we have to use in here. This is the terminal, cmd, clang, common files, a little bit of optimization, right, the executable name. So I wonder if I can, yeah, I can put it like in here, right. So here we are concatenating all this stuff, so this has to be concat. So this is a string. So this is basically what kind of like version like of API of the open source API we use, because some of the like POSIX names are not available with these like sort of macros, so we have to do that. This is another concatenation and all of that in C, right? So like you wouldn't expect this sort of convenience from a C programming language, but this is because we think outside of the box. The convenience of a language is barely dependent on the language itself. It's dependent on what you have implemented in that language, right? Okay, so we'll try to rebuild this entire thing, and that should also start building the terminal demos. Okay, so it's building both the terminal and the WASM, right? The terminal and the WASM. Okay, so that's pretty cool. And the last thing we need to build the SDL, right? And it's also pretty straightforward because it's like a very simple thing. So we probably need to put a to-do in here, right? So because it's not finished, implement copying WASM blobs into WASM folder, right? Because it's quite important, because whatever we copy in here will be eventually automatically deployed to this website, right? Where you can watch the demos, right? So without this specific functionality, we won't be able to properly like deploy things, unfortunately. And if you want to take a look at these demos, you can find them in here. All right. Okay. So where is SDL demo? So let's actually transform this thing here as well. Okay, there we go. So this is a little bit of optimization. O, and then the name, another concatenation. So we're almost done, by the way. So this is another SDL platform, another concatenation. And also the libraries that we link with, right? So with SDL we link with both math and SDL2 library, right? So even though the library is doesn't have any third-party dependencies, when you write an application you need to display it, you still need some dependencies to display it, but you have a freedom to choose what kind of like way to display this thing with, right? Okay, so this is the entire build. We're building the entire thing. All right, so it looks like it's actually building. So it's taking some time because it actually builds sequentially. One of the things we'll have to do, we'll probably have to build some of these things in parallel, right? So one of the things this shell script did is, for instance, it built all of the demos in separate threads. So we can try to do that as well. It should be relatively easy to implement. So essentially, I think nobuild also has a like asynchronous API, something like run async. Yeah, so which is actually pretty cool. Essentially, you can build a command, right? So there are different ways to build a command. You can use the command, how to say, like command macro, right? But you can build the command structure yourself and then pass to a separate thing, right? And that way it gives you a PID. You can basically run several commands, collect their PIDs, and then basically wait on each individual PID separately. And that way you can have several commands running in parallel, right? Because you literally just run asynchronously several processes. I don't remember if it's implemented for both of the platforms. Yeah, so okay, so for Windows it's implemented like that, and for POSIX it's implemented like that. It also accepts like file descriptors. This is needed for piping commands together. So there's also a way that you can run the commands and pipe the output of one command into the input of another. Which is actually kind of cool. So this is what you can do in here, but we'll do that later, a little bit later. Okay, so this rebuilt literally everything, which is kind of cool. So it created the assets. So here is the assets. It also created the tools with which the assets were made, and it also created the demos and also the test tool, right? So we essentially pretty much replicated almost the entirety of the functionality of build.sh. So we can kind of get rid of that file completely, right? But there is another thing. There is another thing that I used to do with this kind of thing. For instance, when I was developing a new demo, quite often I would do the following thing. I would pre-build the tools, the assets, the tests, and everything, and then I will comment out this stuff, right? Because I don't want to build that anymore. And then I would comment out the rest of the demos. And when I'm working for the, like with the specifically WASM version, I also comment out these kind of things, right? And that way I only leave one path. So build that specific demo for that specific platform. Right, but that requires directly modifying this script, which is not particularly convenient. So now, since I have a proper language, I can implement the functionality of the subcommands where I could say something like, right, no build. Okay, I want to build all demos, and because of that, I will have to provide a demo subcommand that will build all of the demos. Right, but what if I don't want to build all of the demos? I want to build only the teapot, right? I would say teapot 3D, and that build only that demo, but all of the three versions, WASM, Term, and SDL. And then I would say, I want to only WASM, and then I can say WASM, right? So now I can develop this system of flexible subcommands where I can narrow down what exactly I want to build, so it's not going to rebuild like everything, because it can take some time, right? So, and for instance, I can rebuild tests, right? So that will rebuild tests. What if I want to run the tests as well? Test run, and it will basically put everything after after this argument to the sub-arguments of the test subcommand and stuff like that. Maybe I want to build only the tools, right, or build only the assets. So now I can do that, and this is what I want to do, but after a small break, right? So because I'm already streaming for an hour, right, so I'm gonna make a break, I'm gonna make a cup of tea, and after the break we can try to implement this system of subcommands, if you know what I mean. Does it sound cool? Doesn't it sound cool? Can your Turbopack do that? I don't think so. Let's make a small break. All right, so let's go ahead and implement the subcommands system. nobuild.c. So what do we want to do in here? I don't remember if go rebuild yourself actually messes with your command lines, so let me quickly check that. Right, I'm gonna just like iterate through all of the commands, like command arguments I have in here. Right, so I can do something like info argv I, there we go, and let's see what we have in here. So I should be able to do something like full bar buzz, there we go. So, and it doesn't really mess with them, which is nice, right? So it still has the program name, which might be useful in the future, and then the rest of the arguments. I wonder if we have the shift thingy that I usually implement for my systems, right? So shift, yes, that's actually perfect. So shift allows me to essentially like remove one of the arguments, right? So essentially if I have arguments like no build full bar buzz, I pass argc and argv to shift, and it will remove the first one, actually returning it through the return value, but it will effectively remove it, and it removes it by decrementing argc and incrementing the pointer to argv, right? So it allows you to sort of like pop out the arguments. Maybe I should have actually called it pop args. Right, so, but this is a very useful operation. I usually implement it for parsing command line arguments because it's rather convenient. Okay, so does it do any checking? So it asserts that I'm not trying to pop out of the empty list of arguments, so which is kind of nice. So in here I can just keep track of the program name. Right, so here's the program, shift args, argc, argv. Zvon codes, thank you so much for the subscription, Raltic25. Thank you. Olex Rise, I hope I didn't miss anyone. Thank you. All right, so then we can do the following thing. If argc is equal to 0, we basically build everything, right? So we didn't provide any command line arguments, we build everything, right? If argc is greater than 0, so maybe we should actually do that the other way around. So if argc is greater than 0, we're gonna try to parse the commands otherwise if it's equal to 0 or less, which should not happen, but argc is integer, so technically it may happen, so it's better to do it like this, in my opinion, right? So usually the last famous words is it should never happen, and then it happens. So you never know. Maybe it will happen when I copy paste this piece of code to a different place, and in that different place argc may become negative. It can only be positive in this specific context, but the context may change. So it's better to make this piece of code robust against any kind of context. You know what I mean? So yeah, anyway. So if it's greater than 0, so we may start looking at the subcommands, what kind of subcommands we can have. So strcmp argv. So first of all, I probably need to like shift the subcommand, right? Const char subcmd shift args. So it's going to be argc argv. So and in here we can start the dispatching, right? strcmp subcmd, and so what kind of subcommands? We probably want to have tools, assets, tests, demos, right? So let's go ahead and do that. So this is going to be tools 0, right? And let's go ahead and do these kind of things. Assets, right? So tests and demos. So otherwise if we have something like this, I think no build had something for the panic, right? Which we can use as well. So essentially panic is like an error, but it also crashes the application. Yeah, there we go. So it just says error, and then it exits with non-zero exit code. So this is something we can do in here. Panic. Yeah, it already prefixes everything. Unknown command, and I think it accepts the formatting, printf formatting. So we can do something like this unknown command. So here we can say tools, maybe this subcommand is not implemented. So this is one of the things we can say, subcmd, and I can just put it everywhere. There we go. Cool. Now, if I try to do that, as you can see, it says unknown command foo, right? Unknown command foo. So if I just try to do that, as you can see, it builds everything. Then I can say tools. Tools subcommand is not implemented, but it should be relatively easy to implement the specifically tools subcommand. We can say build tools, right? And there we go. The tools subcommand is implemented, and in here it builded only the tools, right? So this is actually very simple, very straightforward. So maybe in the future we should be able to also tell which tool you want to rebuild specifically, like tools png to c, right? So right now it will always rebuild this kind of stuff, but it would be kind of nice, you know what I mean? It would be kind of nice. So to do rebuild specific tool, So with the assets, it's also relatively straightforward. Build assets, and again, it would be kind of nice to be able to rebuild specific assets if we want to. So, and this kind of starts to get a shape of more or less generalized framework. Maybe we're gonna implement some sort of a mechanism that allows us to build like a tables of paths of subcommands, and it will automatically like do the rest of the dispatching in here. So right now we do a lot of like manual else ifing. Right, but if we get enough of else ifing, maybe we'll see a pattern that is easy to generalize to some sort of a mechanism. You know what I mean? You know what I mean? And since we're using the proper language, it should be relatively easy to do that. So, all right. Okay. So let me rebuild everything in here. So this is the tools, and maybe let's try to do the tests, right? So the test is not implemented. Kosoban, thank you so much for the Twitch Prime. Thank you. All right. Build tests. Tests. There we go. So this is the build tests. And for the tests, it would be kind of nice to also pass some arguments to the tests utility, right? So build tests run. Right, but right now it's just like doing it like this. So let me actually put it to do rebuild specific assets, to do pass arguments to the test command, right? To the test command, maybe something like build test, and let's run the demos. So to do build specific demos and specific for the specific platforms. There we go. So this is what we're going to be able to do. So let me actually do the following thing. Demos. There we go. Right, it builds everything, as you can see. Okay, that's cool. So I'm gonna probably like do the rest of the stuffs off screen, right? So like the subcommand and stuff like that. So it's probably not particularly that interesting. So let's go ahead and commit whatever we have already. Right, so let me see the readme. So in readme we still, oh, this is kind of like, yeah. I'll probably have to update it as well, but I think on the stream I'll have to update, like I'll update only this specific paragraph. Even though the library does not require any special building, the tests and demos do. Just execute. So we use nobuild, right, nobuild, https github.com nobuild build system. Right, and in here what we do is clang nobuild.c and then nobuild. There you go. So that is basically it, I think. Right, I don't think it requires anything else. So the next step is to delete the sh. I don't remember, did I put it to do about like a parallel running? Yeah. So let's put it to do implement parallel building, right? Okay. And let's remove the build.sh. I also probably need to git ignore no build and no build.old, right? So because I don't really want to commit these kind of things, these executables. So we're gonna have no build and no build.old, right? This is not what I wanted. I wanted just to see what's going on in here. Okay, so that's pretty cool. Let me do a committee. I'm not gonna commit the wasm, so it basically, it probably didn't change anything within the wasm executables. It just regenerated them, and effectively they're different files. Probably some of the bits changed. I don't know why. Like why it doesn't produce the same executable every time. Maybe there is a lot of randomness involved in optimizations or something like that. So I don't know how, like why it is like that. All right, so re-implement, introduce no build build system, right? And I'm gonna push that right into the repo, right? I'm gonna push that right into the repo, and there you go. This kind of thing should be available. So from now on, the project should be buildable with only a C compiler, specifically Clang, right? So we kind of like optimized for building with Clang. Specifically because Clang supports WASM. I think Clang at this point is the only C compiler that supports WASM. I'm pretty sure about that. Right, so yeah. I don't think GCC supports WASM, and definitely Microsoft Visual Studio also doesn't support WASM. So yeah. This is how we use nobuild.